Hello everybody, and today we're going to be talking about quantum theory. So the man on my screen right now is Bohr, and Bohr is a very important figure for what we're going to be talking about in the beginning because of what he found. So this is called Bohr's model, and what he did was he took a hydrogen, just a normal hydrogen atom, and he wanted to show how the electrons move around. So this molecule, this electron is in a ground state. So that means it's very calm and there's not much energy to it. However, this one is when it's in an excited state. So when the electron moves from the ground state to the excited state, this is when the electron is very active and is full of energy. But then what he wanted to focus on was what happens when the excited state goes back to the ground state. Well, what happens is something called a photon is released, and that's basically just the stored energy that was in the excited state. And he said that when these photons are released, there's these frequencies that can be emitted, but there are only certain frequencies that can be emitted because you can't have infinite amount of frequencies for one thing. It's like a ladder. You can't have from going from one rung to the next one, you can't have all these different possibilities on how to do it. There's only a certain amount of ways to do it, and that's what he was trying to prove. And this is the equation that he ended up coming up with to show this change. So this is what he said. So when the photons are released, they release these lights. So when you have these ultraviolet lights and the infrared, those are the ones that we can't see. As mammals, we can't see these lights. But the visible series and the Bohrs are the ones that we can see. So depending on the different levels that they're coming from to the level that they're going to, it displays a different amount of light for the different frequencies. So people believe that, but then one man, Louis de Bogle, right here with the amazing mustache, showed that some parts of it were true. Yes, it's true that there's only a certain amount of frequencies possible, and there had to be an odd number of wavelengths that were allowed. And what he decided to focus on was the fact that light has both wave and particle characteristics. So do other things have the same as well? And it was true. He decided to state that all moving particles have wave characteristics. And so this changed the game. And he said that if electrons have wave-like characteristics and they have a certain amount of radius, then there had to be certain frequencies. And there only is a limited amount of frequencies that can come from these actions. And so he decided to use his knowledge and come up with a principle. So this is wavelength equals Planck's constant over the mass of the object times the frequency. So next up we have Heisenberg, and Heisenberg really made some scientists mad because with his Heisenberg uncertainty principle, he basically said that you can't measure both the position and energy of an electron at the same time, because if you mess with one, the other one will also have a reaction. It's like if you're trying to decide the balloon's position, but then you touch it to see how it moves, then you're losing the position. So you're unable to do both at the same time. And this made a lot of scientists mad. And next up, we have Schrodinger. And Schrodinger came up with the quantum mechanical model. And this basically, it shows those same frequency limits. But what Schrodinger decided to focus on was wave function. And wave function basically shows where the electron is. And so this is the equation that you can come up with. And what Schrodinger found was that there's a higher chance of finding these electrons near the nucleus. So this is closer to the nucleus on this side, and see how it's very, very high chances of finding our electrons near the nucleus. And then as you go through the different levels, you're kind of having it, but it's just a bit of delayed. And then what Schrodinger said was that there are in these orbitals, and these orbitals are very important. So this is the s orbital closest to the nucleus, and then p, d, and f. And the ways to remember, this is a sphere, these are dumbbells, this kind of looks like a clover, and this one is hard to explain. But what basically he's saying is that depending on where it is, these orbitals are where the electrons are. So if you want to find them, this is where you have to start looking. So yes, that is how quantum theory is able to be explained.